Okay, so section 10.1 about polar coordinates is kind of long, so I decided to split it up into um, two sections. Just go through part one. We're going to go through objectives 1 through 4 today. So just in case you were wondering, this would be related to, there are 63 homework questions in the whole entire section. Numbers 1 through 5 are just review of general topics from chapter 6 and also chapter 7, just reminding you about whether or not you can evaluate trig function values of special angles on the unit circle, as well as the inverse from chapter 7. So make sure you have your half circles for the chapter 7 questions a little bit when you do inverse sine, inverse cosine, inverse tangent. But section 10.1 is about polar coordinates and polar equations. You probably haven't measured in polar form before. Polar coordinates are really great for trying to describe a directed distance, which is kind of what we talk about in this form. So they're a lot like vectors. You want to be able to describe to a person that they would turn a specific amount of degrees and then maybe radiate out from the spot where they are standing a certain amount. So the way that I like to ask you to visualize this a little bit with your eyes closed. Sometimes I'll say, okay, just imagine that you're standing at the North Pole and that you see a whole bunch of concentric circles, right? Like the ripples in a pond radiating out from you. And you're standing, like, let's say, at the origin of the X and Y axis, and you're facing the positive X axis. Okay, and then the theta in the coordinates r theta would represent the degree angle, or the angle in radians or degrees that you would turn or rotate clockwise or counterclockwise. And then the r represents the amount of units that you would radiate out from that spot, like a circle, like the radius of a circle. So if you were going to rotate, we're going to talk about some in just a minute, but like let's say you were going to rotate, you had an polar coordinates of something like 2 and pi over 3, then you would kind of rotate to pi over 3 from the positive x-axis, and then you would radiate out 2 units, like in a circle. So there's some general information about the definition of directed distance a little bit. Remember that be careful if r, one thing that you may want to note in this box in particular is that if r is less than theta, then you are going backwards after you rotate a particular direction. So if you think about what you're doing, you would kind of step backwards and instead of stepping forwards, radiating out of the circle a little bit. And then if it's 0, then you would not turn at all. You would just go by degree measure. When you plot polar coordinates, you should be looking at a blank polar graph, which looks something like what you see here. You have concentric circles, and you typically that have different radii, like 1, 2, 3, 4, 5, so forth and so on. And then oftentimes you're going to see these angles, especially the special angles, already marked on your unit circle a little bit, or already on your graph. Okay, so these first sets of questions is going to address numbers 6 through 13 in your homework assignment, and it's just about plotting points in the coordinate system. Here's the weird thing. You know that when you plot points in the rectangular system that you travel x units horizontally left and right first, and then you go y units vertically. In this case, I think it's much easier if you rotate first. So I want you to rotate according to the degree first, and then go out radius units, however, after that. Okay, so because this says 150 degrees, remember we always start with an initial side on the positive x-axis, and then we're going to rotate to 150 degrees, which obviously on this graph corresponds to 5 pi over 6. And then you're going to, from that, after you turn to face that direction a little bit, then you're going to radiate out 3 units to a circle with a radius of unit 3. So we're going to get 1, 2, 3. And the point that we are going to plot is right here. Okay, and if you had to draw the angle, you could draw the angle, but in general, you're just plotting point B. There it is. Okay, and in the next one, what we're going to do is notice that this negative right here means backwards. So after you turn to 5 pi over 4, you're going to step out backwards instead of in the same direction that you're facing. So the first thing that we're going to do is we're going to start on with an initial side on the positive x-axis. We're going to rotate to 5 pi over 4. Remember that 5 pi over 4 is in quadrant 3 over here. Got it? So you turn and you're facing this way, but this number, -1, tells you to step back 1 unit from there. So I'm going to end up right here, and this is point C. And this is point C with a radius of -1 and at 5 pi over 4, where the R value is -1. It doesn't really mean that your radius is -1. It just means that you're going backwards instead of going forwards in polar form, okay? All right. The next one, point E, is R is 4. And theta is -5 pi over 6. So since theta is negative, we need to rotate clockwise, remember that, to -5 pi over 6. And if you forgot, remember that you can always pull up a graph. But remember that all of your values on the unit circle flip over the x-axis when you are trying to determine where that negative angle would be. So if positive 5 pi over 6 is in quadrant 2, then -5 pi over 6 is in quadrant 3. And it flips down and it ends up over here. So this is -5 pi over 6. And then we're going to radiate out 4 units. So we're going to go 1, 2, 3, 4. Right here is point E. And this is point E at 4, -5 pi over 6. Excuse me. All right, and point H. Now we're going to rotate clockwise because it's a negative angle. And we're also going to go backwards because the value of R is -3. So we're going to rotate to -7 pi over 4, positive 7 pi over 4. Positive 7 pi over 4 is in quadrant 4. So if you flip it over, then -7 pi over 4 is in quadrant 1. So remember, we're rotating clockwise over here to -7 pi over 4. And then we have to go back 3. So you're kind of facing that direction, but then you have to radiate back 3 units. So after you've turned and you're facing that particular direction, now you got to go back 1, 2, 3 units. And here you are at point H, where R is -3 and theta is -7 pi over 4. And that's how you plot points in polar form. Okay, moving on. And I think I already addressed that was like 6 through 13. Good. Okay, so moving on to the next page. All right, so objective 2 is about determining different representations of a point. So there's lots of different ways that you can talk about a point in polar form, like we can talk about R being positive or negative, and we can talk about theta, and remember that there are an infinite number of angles that are coterminal with theta. So you can always add 2 pi, you can subtract 2 pi, you can add more than 2 pi, you can add 4 pi, 6 pi, 8 pi, as long as it's coterminal, but remember that has to be an even multiple. So there's a box here that kind of gives you some general information about that. And then a point located at the pole has coordinates 0, theta, and theta is any angle. So then I'm going to turn over here. So I want to talk about these types of questions. We're going to plot and give different representations. So let's talk about this. These would represent questions like in the homework number 14 through 18. And we are going to do some different representations. So the very first thing we have to do is we have to plot. So we're going to rotate to 4 pi over 3. Remember, we're starting on the positive x-axis. 4 pi over 3 is here. We're going to radiate out 1, 2, 3 units. So here's point P right here. Then the next thing it's going to ask you is, now it's asking you to give a different ordered pair. So I'm going to put this in a different form. I should have underlined this in green right here. I'm going to put this in blue. And we're going to say, I want a different, something that looks slightly different. I want the value of R to be positive, so I still want this to be 3. That's okay. But the problem now I want the value of theta to be between -2 pi and 0. So what I want you to do is, we're going to take that 4 pi over 3, and all we need to do is subtract 2 pi. And remember that 2 pi is the same as 6 pi over 3, so you should end up getting -2 pi over 3 for the coordinates for part A. Then we're going to try to talk about part B. Let's talk about part B. We now want the value of r to be negative. So now I'm going to be a little bit more careful, and I want theta to be a positive angle between 0 and 2 pi, right? But somehow I'm going to have to be able to rotate and get that value of r to be a negative number. So I have to make sure that I'm rotating properly a little bit, okay? So in order to think about that, what I'm going to do is I'm going to actually rotate. I got to think about the fact that I want to rotate and then go backwards. So what I'm going to do is I'm going to look for something that's in line with the fact that I still need to end up here at point P. So what I'm looking for is something that lies on the same line. So my line of sight is kind of going over here to this pi over 3. So if I rotate to positive pi over 3, but then go backwards, so I'm going to show you what that looks like one more time. I'm going to get rid of this dashed line right here and say, okay, if I rotate to positive pi over 3, but then go backwards, 1, 2, 3, that ends up at the same exact point P, and then we're where we need to be. All right, so normally I look for what's in line with that, but as a positive angle. So I think about the fact that I would have to be going backwards, and then I look for what's in the same line as that. There's probably more formula-driven stuff on the other page, but I just like to try to draw it visually. And then the very last thing that we're going to do is talk about, all right, well, what if we want to have something that's greater than 2 pi? That's probably the easier one, because now, just like in part A, you subtracted, what we're going to do is notice that the value of r is positive again, so I'm going to go back to having the value of r be 3. And then I'm going to take the 4 pi over 3, and I'm going to do plus 2 pi. Again, remember that's 6 pi over 3, so that's going to end up being 10 pi over 3, right there, 10 pi over 3. Still the same thing, still the same point. It just means you've gone an extra revolution. So really what we did was this. To get to 10 pi over 3, I rotated to 4 pi over 3, and then I rotated another full revolution of 2 pi from there. So I still end up at the same place, and then radiate out 1, 2, 3, and we still end up at point P in quadrant 3. It's the same exact point. You should always end up at the same exact point. It should be just different ways of saying the same exact thing. Got it? All right, the objective 3 is how to convert between a point in polar form to a point in rectangular form. So we say we want to get x and y from the polar form. And it's pretty formulaic. It's not really a lot of thought process to it. You're just going to take the value of r and multiply by the sine or cosine value of theta, okay? So it's just not a lot of thought process to this. This is probably about the easiest thing to do. I bet you I didn't tell you which homework problems were different representations. Did I do that? Yep, sure did. Okay, so objective 3 has to do with determining rectangular coordinates, and that would be problems like homework number 19 through 24. Okay, so when we want to get rectangular coordinates, remember that r is -5, theta is 3 pi over 4. So we're going to say x equals, and that's what we're looking for. We're looking for x and y. These are the unknowns right here, right? Okay, so x is equal to r cosine theta, and that means we're going to do -5 times cosine of 3 pi over 4. And you know that cosine of 3 pi over 4 is in quadrant 2, cosine is negative, and that's going to be 1 over root 2. So that's going to be 5 over root 2. That's the value of x. Got it? Now y is going to be r sine theta, which is -5 sine of 3 pi over 4. And in quadrant 2, sine is positive. So that's going to be positive 1 over root 2. And then your r value is going to be -5 over root 2. And then make sure that you type coordinates, because you are kind of required to do that. So you have 5 over root 2 and -5 over root 2. Make sure that you're taking care of that business. And it's always x and then y first. Remember that? All right. I'm not sure if there's another question like this, but let's take a look and see. All right, nope. Moving right on to objective 4, because objective 3 is just really, really basic. It's just plug and chug into the formula and you've got it. Objective 4 has a little bit more thought process. So there's a whole lot of information about On this particular page, there's a lot of information about the fact that you might have just a value for r, but theta is equal to 0. And again, you might have theta is equal to pi over 2. So there's a lot of very basic things here. When you have a terminal side on an axis, then it's pretty basic. You just want to pay attention to what you're going to do a little bit, and notice that here's the problem with these that lie on the axis. Remember that tangent is undefined a little bit on some of these things. So these are really, really very particular when they lie on the axis. And in case you're wondering, this would be like homework problem numbers 25 through 28, and it is better to figure out the polar coordinates from rectangular. Here's x, here's y. It's better to figure out the polar coordinates from here just by thinking about the graph, okay? Way easier than trying to make it too complicated. So we want to plot the point 0, negative root 2, and what I'm going to do is just say, okay, here is negative root 2 right here, all right? And of course I did that wrong because I didn't go on the y-axis, excuse me. All right, 0 for x because I'm already thinking in polar, and then negative root 2 right here. So here's where we are, all right? And we need polar form, which means we need to know what is r and what is theta. Well, theta should be the easiest piece because imagine that you're starting with an initial side on the positive x-axis and you rotate over here to the negative y-axis, then you already know that that's 3 pi over 2. And notice that it does want you to put theta in between 0 and 2 pi, so that's critical. The r value should just correspond to whatever number you are given, so you're just radiating out negative root 2 units. And I'm sorry, excuse me, we don't want the negative right there because we wanted r to be positive. So we're just going to say that r is just the absolute value of whatever number you have because theta has to be between 0 and 2 pi. I'm going to give you one more example because I just did a pretty lousy job with that one. So let's say we have the point Q, and that point Q is, let's say it's at negative 3 comma 0. All right, so I'm going to sketch that on the x-axis, negative 3, 0, 1, 2, 3. Here we go. Here's negative 3, 0 right here. So the first thing I'm going to do is I'm going to determine what theta is. I'm starting on the positive x-axis and I'm rotating here. So you should already know that theta has to be pi. That's the easy part. And then if you've turned and you face this direction, but you're stepping out 1, 2, 3, then the r value is 3. That's radius units. And that's what it is in polar form for r theta. Sorry, I had to redo that one just because I thought that that particular example was bad. On the next page, we're going to talk about what happens when it lies in a quadrant and not on an axis. These particular problems should be a little bit easier, but it is definitely better to visualize it than to try to do a formula for it. That's not really a good idea. All right, when it doesn't lie in an axis, remember that x squared plus y squared is equal to r squared. So if you need to find a value for r, you can always take the square root of x squared plus y squared. You do want to determine which quadrant something lies in, and then you're going to have to solve tangent theta equals absolute value of y over x. So remember that the reference angle is going to be equal to inverse tangent of y over x, and just be careful about that a little bit because you do need to pay attention to kind of which quadrant you end up in. These are a little bit more challenging, so there is that you have more multi-step problems with these on purpose, and that is by design. And then there's some formulas about how you can get theta by subtracting the reference angle from pi if it's in quadrant 2, adding pi to the reference angle if it's in quadrant 3, or subtracting the reference angle from 2 pi. So I think on the next page is where you're going to see a 5-step problem. So here we go. We have something in rectangular form, x and y, and we want to convert to polar form. So first thing you're asked to do, and this would be, these problems will be like numbers 29 through 34. Okay? All right. So we're going to find the value of r. First thing we're going to do, if you prefer to just write r is equal to the square root of x squared plus y squared, it really doesn't make any difference. They're all the same as long as you figure it out. So square root of negative 5 squared plus 5 root 3 squared and negative 5 squared, then you get 25 and 75, and this is going to end up being 10, right? So the value of r is equal to 10. In which quadrant does point P lie? Now you want to pay attention to the fact that the original point P that was given up here at the top was negative 5 comma 5 root 3. Remember there that you have a negative x and a positive y. So that must be quadrant 2, right? If you have a negative x and a positive y, it has to be in quadrant 2. Why do you need to know that? Well, you need to know that because you got to be able to find what that angle is in quadrant 2. Okay? So now we're going to try to find the value of the reference angle, which means we're going to do inverse tangent. So I'm going to take the inverse tangent of 5 root 3 over 5. Remember that up in the box at the top, it just says something about absolute value. So I'm just kind of pretending that I'm doing that a little bit. I'm going to cancel that, and then you're left with inverse tangent of root 3. So that would be your reference angle. When we evaluate this, you're going to get your reference angle. So remember that you're asking yourself, which angle has a tangent value of root 3? And your answer to that ought to be pi over 3 if you remember your values from your unit circle, okay? So then when you want to find, and you can use, again, the boxes at the top. But we need to find the angle that lies in quadrant 2 that has pi over 3 as a reference angle. So the formula that you're going to use should be pi minus the reference angle, right? Because we are trying to get into quadrant 2, somewhere over here, right? That's the angle that we're looking for, and the value of the reference angle would be this value. That would be pi over 3, okay? So you're going to have to do pi minus that to get that. All right, so when you do pi minus pi over 3, you should get 2 pi over 3. If you already know all of the angles on the unit circle, then obviously this point is kind of tedious when it asks you about like which quadrant is it in and knowing all that, but when you get to the mixed review section, it's not going to be quite that bad. And so the polar coordinates, remember we found the value of r up top to be, found the value of r in step 1 to be 10. And you just found the value of theta to be 2 pi over 3, and you're done. And that should be the end of that, okay? We're going to do one more, all right? So I'm going to find the value of r first. First, I'm going to find the value of r, so I'm going to do the square root negative 4 root 3 squared plus negative 4 squared. So this is going to be 48 plus 16, and that's going to be 64. So the value of r is going to be 8, okay? And then I need to, I'm going to skip a couple of steps right here. I just want to think about which quadrant, because remember, you always need to be careful about which quadrant you are in. If I could spell quadrant, that would be delightful. Okay, so we must be in quadrant 3 because we have a negative and a negative from this ordered pair over here, right? Okay, now we're going to do inverse tangent. And we need to know the quadrant because we're going to have to name the angle appropriately based on the quadrant that it lies in. So now we're going to do inverse tangent of negative 4 over negative 4 root 3. And it would be absolute value, so these are just going to go away. So I've got inverse tangent of 1 over root 3. So the reference angle that I'm looking for, theta, is going to be equal to pi over 6. Right? But I need to get the angle in quadrant 3. This is theta sub r. That's the reference angle. So in quadrant 3, theta equals 7 pi over 6. Got it? So your final answer for polar form, polar coordinates, should be 8, 7 pi over 6. And we're done. Sorry that took so long.